Okay, for organic skills training exercise 2, question 2. We are looking at a chemical test question. So for chemical test question the skills involved is to find out all the functional groups present and then find the difference between the functional group to propose suitable chemical tests. So in E, we have a ketone, but very specifically you can see that this group here is a CH3 C double bond O. Alright, it's a methyl ketone. Okay, as a result, you can use your iodoform to test for E. You also have a secondary halogenal alkane in E. For F, you have highlighted in green a phenol functional group. In yellow, you have an aldehyde functional group. And in G, you have an alkene and a primary alcohol. So in this case, we are supposed to give a positive test result for E. Alright, so almost instantaneously, you guys will think that, okay, I can make use of the methyl ketone. I can propose an iodoform test. Yes, that's true enough. I can make use of the methyl ketone. I use alkaline aqueous iodine and heat it. I will get a yellow PPT of CHI3 for the methyl ketone. Alright, compound E. But whereas for F and G, because there's no methyl ketone or methyl alcohol group, you will not have any yellow PPT. Alright, what's one more test that you can target for for E that gives a positive test? So other than targeting the methyl ketone, you do realize that there's a halogenal alkane group that's present inside E that can be tested for. Alright, so the rest of F and G does not have your halogenal alkane. So in this case, to test for halogenal alkane, we can make use of the three-step process. I make use of NaOH, aqueous, and heat. This reaction is basically your nucleophilic substitution reaction. Basically, your Rx will become ROH plus your X minus. So in this case, you add your OH minus, aqueous, and heat. Alright, so X minus in this case will be your Br minus. And then we need to test for the Br minus. Okay, but before we test for the Br minus, we need to add in some nitric acid. So step 1, NaOH, heat. Step 2, we add nitric acid. What is the nitric acid used for? It is to neutralize away the NaOH. Alright, this is to prevent any reaction between NaOH and silver nitrate. So in step 3, we add silver nitrate. The silver nitrate is largely to test for the X minus, just like what we do for inorganic QA. We get your AgCl white PPT, AgBr cream PPT, and AgI yellow PPT. Okay, so these are the things that we can do for your halogenal alkane. So again, remember the sequence. You add NaOH, aqueous, and heat to free up the X minus. Add in nitric acid to neutralize the excess NaOH to prevent any reactions of the NaOH with silver nitrate. And last but not least, add in silver nitrate to test for the X minus. Okay, so in this case, you get your cream PPT of AgBr for E, but no cream PPT for F and G. Okay, moving on. We're supposed to test for compound F. So compound F have two very unique functional groups here. We have phenol, that's not shown in E and G. We also have an aromatic aldehyde. So this aromatic aldehyde, you can see, is connected to the benzene ring. Alright, this aldehyde is connected to the benzene ring. So we can make use of the phenol functional group. We can add in neutral aqueous iron trichloride. This is a very classical test for phenol. So we have a violet complex, and then we have no violet complex for E and G. Now, some of you may be tempted, alright, to use aqueous bromine to test for phenol. But in this case, aqueous bromine will not be a suitable test. So why is aqueous bromine not suitable? True enough, aqueous bromine will get substituted on the benzene ring, and therefore you can dechlorize your aqueous bromine for phenol. But because of the alkene functional group in G, aqueous bromine will also be dechloroized with the alkene. So in this case, aqueous bromine will not be suitable, and therefore we have no choice but to use the very classic test for phenol, which is your neutral aqueous iron trichloride. Okay, for F, another test possible will be to target the aromatic aldehyde. Alright, aromatic aldehyde. So what test can be test for aldehyde because in E there's no aldehyde, in G there's also no aldehyde. So we can make use of the aldehyde test. In this case, I can use the Tollens reagent to test for it. So I will get my silver mirror for F, whereas there's no silver mirror for E and G. Okay. Naturally, you will have a question whether can we add failings? So question mark. Alright, can we do failings test? Alright, so in this case, failing test will be a no-no. Why? Because failings test tests for aliphatic aldehyde. Okay, so with that, we are done. I just have a quick question for you to think about. Can you think of a test that can be used specifically for compound G? So if you think like compound G itself, what chemical test can you use that gives a positive result with G but a negative result for the rest? Okay, you can pause the video now to start thinking about it. So I repeat myself again. Can you think of a test specifically for compound G? Compound G, alright, that gives a positive test, negative test for the two. Alright, you can pause the video, try to work it out, and when you're ready, you can resume to play the video. Okay, time to review the answer for this additional challenge question. We are making use of the primary alcohol in compound G. We can make use of anhydrous PCl5. So the primary alcohol will undergo nucleophilic substitution, and you will observe white films of HCl observed for compound G, whereas in E and F, there are no functional groups that can react with your PCl5. Okay, so G, you can make use of the alcohol, react with PCl5, you get white films. F and E will not give a positive any positive test. Okay, with that, we are done with question 2.